this video, I'm going to do a quick review of those one-step equations you learned about last year as sixth graders. And our objective is I can solve one-step equations resulting from word problems, because really overall in this unit, we really want to be able to take word problems and translate them into equations, but we have to know the skills of solving equations before we can handle them with word problems. So let's just remind ourselves. To solve an equation, we have to remember to use opposite operations. So for example, if you were given an equation that said y plus 14 equals 20, to solve for y or get y all by itself, you have to undo this addition. How do we undo addition, or what's the opposite of addition? It's subtraction. So to get y all by itself, you'll remember from last year, you undo addition with subtraction. You would subtract 14 on the left side. Those would zero out. Those are opposites or additive inverses. Then on the right side, whatever you do to the left side of an equation, you do to the right side. 20 minus 14 is 6. So this equation, y equals 6, is the only value that makes this equation true. You'll remember from last year, when you check, like, does 6 actually make the equation true? You substitute 6 back in place of y, and you would do 6 plus 14. Is that really 20? Oh, 6 plus 14 is 20. That makes a true statement. We've solved this correctly. Here's an example of a one-step equation that involves subtraction. We know the opposite of subtraction is addition. So if you were trying to solve this equation, x minus 120 equals 80. We're like, okay, we're trying to get x all by itself on one side of the equal sign. So I have to get rid of this 120. I'm subtracting by 120. How do I undo subtraction? What's the opposite of subtraction? The opposite of subtraction is addition. That means in order to get x all alone, I would have to add 120 here. Minus 120 plus 120, those would zero out. I'd be left with x. But if I add 120 on the left-hand side of the equal sign, I also have to make sure I add 120 on the right side, so the equation will stay equal. And so 80 plus 120 is 200. So the only value for x that makes this equation true would be 200. And you could always check that. X minus 120 equals 80. Last year you probably called these your checks. So when we find out we think x is 200, let's substitute it in. 200 minus 120, I'm hoping that's 80. Well, what's 200 minus 120? Oh, 200 minus 120 is 80. 80 equals 80. Beautiful. Here's a multiplication example. If this is 3n equals 12, you need to know that means 3 times n equals 12. How do we undo multiplication? We undo multiplication with division, because the opposite of multiplication is division. So to get n all by itself, how do we undo it being multiplied by 3? We divide the left-hand side of the equal sign by 3. If we're dividing the left-hand side by 3, you go to the right-hand side of the equal sign. You must also divide that side by 3. I like the fact that they use a fraction bar. That's how we handle it in middle school. 3 divided by 3 is a fancy form of 1. 12 divided by 3 is 4. So 4 is the only value that will make this true. We could substitute the 4 back in. 3 times 4 really does equal 12. Let's just quick look at a division example. So if you were given this equation, k divided by 2 is 16, you have to know, how do we undo division? Oh, we undo division with multiplication, because what's the opposite of dividing? The opposite of dividing is multiplying. So to get rid of this 2 and have k all by itself, you say, what had k been divided by? Okay, had been divided by 2. I'd really prefer a dot here, or a parenthesis. So I'm going to multiply this side by 2, because 2 divided by 2, fancy form of 1, those are gone. If I'm going to multiply the left side by 2, I also multiply the right side by 2. 16 times 2 is 32. So the only value that makes this equation true is 32. If you took that 32 and substituted it back in place of k, 32 divided by 2 really is 16. All right, let's try some examples. They ask this quite a bit on the state test. So it says, which equation is true when n equals 4? Well, we could substitute n equals 4, and we can figure this out. So, but I also want to talk about if we were going to actually solve these. But if you want to just check if a solution if something is a solution to an equation, you can always substitute what they give you in. So you see how this is 2 times n is 6? Well, I could do 2 times 4 and see if that's 6. What's 2 times 4? 2 times 4 is 8. 8 does not equal 6. 4 is not a solution to that equation. So let's try the next one. N plus 3 is 7. Substitute a 4 in place of n. Is 4 plus 3 7? Oh, 4 plus 3, 7 equals 7. That one does appear to be true. This is just how we check our equations. We substitute in. So now I could substitute in the 4 in place of n here. 9 minus n is 13. I could always do 9 minus 4 and check if that's 13. Oh, what's 9 minus 4? Oh gosh, 9 minus 4 is 5. 5 doesn't equal 13. So we know 4 is not a solution to that equation. Substitute 4 in place of this n. We have n over 12 equals 3. Well, if I put a 4 in place of n, 4 over 12, that does not equal 3. 4 over 12 is actually 1/4, or 0.25. All right, so that's just a quick review of checking equations, taking what we think is a solution and substituting it back in. Now let's actually go through the process of solving some one-step equations. This is from the New York State Assessment. What value of y makes the equation true? Again, we could guess and check and substitute in, but we just go right here and we say, okay, this is y plus 2.9 is 11. I want y all by itself, so I have to undo this addition. How do I undo addition? I undo addition with subtraction. The opposite of addition is subtraction. So to get y by itself, I need to subtract 2.9 on the left side of the equation. If I'm going to subtract 2.9 on the left side of the equal sign, I also have to subtract 2.9 on the right side. And then I'm going to go ahead and line up my place values. I have to here put a 0.0 because I didn't have anything in the tens place here. Can I take 9 from 0? No. This becomes a 10, right? Bar from there, that becomes a 10. 10 minus 9 is 1. And then here on this side, I have 10 minus 2 is 8. 8.1 must be my final answer. 8.1 plus 2.9 must give me 11. We could check it if we want. Y plus 2.9 equals 11. In place of y, this would be called a check. In place of y, I could always substitute 8.1. 8.1 plus 2.9, I'm hoping that's 11. 8.1 plus 2.9, 9 and 1 is 10. 8 and 1 is 9, and 2 more is 11. 11.0 is 11. That checks. Let's try another one. This one involves subtraction. It says, what is the solution to the equation below? This is not a multiple choice. You're not given a multiple choice. You can't guess and check. The last couple of problems, we could have substitute values in and checked. So what we have to do is we look on the side with the k, and I say, okay, I want to get k all by itself to figure out the solution. What number works for k? What's the opposite of subtraction? Oh, the opposite of subtraction is addition. So to get k by itself, I need to undo this subtraction. I need to add 8.63 to the left-hand side. If I'm going to add 8.63 to the left-hand side of my equal sign, I need to add 8.63 to the right-hand side. First of all, these zero out. They are additive inverses or opposites. So on the left, I just have k equals. Here, I've lined up my place values. I need to add a 0 placeholder. 1 plus 0 is 1, 0 plus 3 is 3, 0 plus 6 is 6, 8 and 1 is 9. Looks like the answer for k is 19.631. Again, I could substitute back in, and I'm telling you, if you take 19.631 and you subtract off 8.63, you will come up with the other side, 11.001. So the value for k that works is 19 and 631 thousandths. Let's try another one. A lot of times these are going to be asked in terms of word problems, so that's where we want to get to. It says John's friend told him that he could earn $49 handing out flyers at a local concert. John wants to calculate the hourly rate. If he works a total of 3.5 hours, the equation 3.5x equals 49 can be used to determine his hourly rate. Because if you took the number of hours worked times the amount of money you make. That'll give you the total cash you get. What would John's hourly rate be? 3.5x equals 49. All right, so we look at the 3.5. The operation between that and the x is multiplication. What's the opposite of multiplication? How do we undo multiplication? We do undo multiplication through division. So now I have x equals, I have to do 49 divided by 3.5. So I'm going to bottom out 3.5 into 49. You need to have a whole number on the outside of the division box, so I have to move this decimal over 1, which means I'd have to move this decimal over 1, and I'm really going to do 35 into 490. 35 goes into 49 once. Subtract off 35. 9 minus 5 is 4. 4 minus 3 is 1. Drag down a 0. How many times does 35 go into 140? I don't know. Let me try 35 times 5 and just see what happens. Nah, it's not going to end in a 0. 5 times 5 is, that's going to be over 150. Oh well, 5 times 5 is 25. 3 times 5 is 50. That's 175. That's way too high. But if we try 4, I bet it'll work. 35 times 4. 5 times 4 is 20. 3 times 4 is 12. 13, 14. Oh yeah, that totally works. So the hourly wage is $14. Makes $14 an hour. There you have it. Let's go to another one. Let's try some equations with some fractions in them. It says, what's the solution to the equation below? So I'm trying to just solve for W. For W equals 2/3. What's the operation between the 4 and the W? The operation between the 4 and the W is multiplication. How do I undo multiplication to get W alone? I undo multiplication through division. So I'm going to divide the left side by 4. That means I also have to divide the right side of the equal sign by 4. 4 divided by 4, fancy form of 1. I have W equals, and then on this side, this is 2/3 divided by 4. 2/3 divided by 4. 4 is the same as 4 over 1. 2/3 times, changing your division multiplication, taking the multiplicative inverse here. A multiplicative inverse of 4 over 1 is 1/4. Straight across the top, straight across the bottom, we get 2 over 12. We can simplify that. Dividing top and bottom by 2, you get 1/6. W must be 1/6. Ah, they didn't even simplify it. They left it as 2/12. This is actually a 6th grade release date test question. That's interesting. So they left it as 2/12. That's fine. All right. There's another one that was asked last year on the New York State grade 6 exam. It says the area of the triangle below is 2/5 square feet. They give you a beautiful picture. They even show you the height of your triangle is 6/5. What is the length in feet of the base of the triangle? Okay, so area equals 1/2 times base times height. So you have to know your formula for your area of your triangle. Now you're going to have to substitute in the values they give you. They say area is 2/5. So in place of A, I know A is 2/5 equals 1/2 times, do I know my base? I don't. I could call my base B. Times, do I know my height? I sure do. My height is 6/5. And now I'm going to go ahead and solve this equation. I'm going to look on this side with the B. I'm trying to solve for B. So let me just multiply on this side what I can multiply together. 1/2 times 6/5. Multiplying straight across the top, straight across the bottom. That gets me 6/10. 6/10 is the same as, if I divide numerator and denominator by 2, 6/10 is the same as 3/5. So when I multiply these two fractions together, I really have 3/5 times B equals 2/5. What's the operation between the 3/5 and the B? Well, that's multiplication. How do I undo multiplication? I undo multiplication with division. So to get B all by itself, I'm going to divide the right-hand side by 3/5. If I'm going to divide the right-hand side of my equal sign by 3/5, I need to divide the left-hand side by 3/5. I hope I don't run out of time. I'm going to. 2/5 divided by 3/5. 2/5 divided by 3/5 is 2/5 times 5/3. 2/3 is going to be your answer.